Hello. Electronic instruments are the integral part of every electronic laboratory. There are a number of electronic instruments. The main purpose of electronic instruments is to measure different electronic quantities such as voltage, current, resistance, power, frequency, phase. The another most important application of the electronic instruments is to test the electronic circuits which we have developed in our laboratory to test its performance. There are a number of electronic instruments that we are going to discuss, out of which the very first electronic instrument that we are going to discuss now is the digital multimeter. Digital multimeter is the instrument which is going to show us the quantities which are to be measured with the help of the digital display. That's why it is called as a digital. And second is why it is called as multimeter, because it is not just a voltmeter, current meter, ohm meter. It can measure the voltage, current, resistance, and that's why it is called as a multimeter. It can also measure the voltage and current both in AC or DC form. Let us see the internal block diagram of the electronic digital multimeter. This is the simplest block diagram that I have shown you here. If you see that there are some blocks which are very common, that means buffer amplifier. So there is one buffer amplifier here. The calibrated attenuator here is, the current voltage converter is here. Okay, the rectifier circuit, the constant current source, analog to digital converter, and digital display. You can observe one thing: the analog to digital converter and digital display is common for all these particular blocks. The main purpose of digital multimeter is to measure resistance, AC voltage, AC current, DC voltage. And for that, to measure the different quantities with the help of this meter, we are going to switch the different circuits which are supposed to do the different quantities measurement with the help of the rotary switch. So this is the input terminals. These are the input terminals. And this main input terminal can be switched to either measurement of resistance, measurement of AC voltage, measurement of AC current, measurement of DC current, measurement of DC voltage by using the switch which is known as a rotary switch. So we can rotate that switch and we can connect this common terminal to any of the input circuit. Now let us discuss how the actual measurement takes place. Here in this case, when I switch it to resistance measurement, if you can see that there is a one connection that has been made up here. If I switch this rotary switch to resistance measurement, a constant current source comes in the picture. It comes in the circuit. This main thing about the constant current source is it can supply very constant current into the circuit. This constant current is been flowing out of that constant current source. It comes through this rotary switch, and then whatever the resistance that I want to measure, I have connected here in between the input terminals. So this constant current source then starts flowing out of the constant current source, flows to the rotary switch, flows through this unknown resistance. And because of the passing the current through that unknown resistance, there is a voltage drop that is being developed across that resistance. Now we know that the current which is been passing through that resistance is known and which is constant, but the resistance value is unknown. And so the voltage drop that is being developed here is proportional to the resistance. right? So what we have done is we have converted this current by using that resistance into proportionate voltage. That voltage is then been applied to the buffer amplifier. Now, what is the purpose of buffer amplifier? The buffer amplifier is going to amplify the signal, match the impedance of that particular resistance with the analog to digital converter and supplies that voltage to analog to digital converter. The analog to digital converter converts that analog voltage into proportionate digital signal, and that is been supplied to the digital display, where the digital display is going to show us the voltage with the help of the decimal digits. So this is how the current is been converted into voltage by using that unknown resistance, and we can directly calibrate the digital display in terms of the resistance. There are a number of ranges of that resistance. So 2 ohms to 20 ohms, 20 ohms to 200 ohms, 200 ohms to 2000 ohms, 2 kilo ohms to 20 kilo ohms, and so on. So we can select the proper range of that resistance and we can have the measurement. So this is about the resistance measurement. Now we'll come to the AC voltage, AC current, DC voltage, DC current measurement. Now, whatever the voltage or current that we want to measure, that voltage or current is been applied here across the input probes. Then that voltage is been applied. For example, if I want to measure the AC voltage, then I have to connect this rotary switch to the terminal number 2. The AC voltage then gets applied to the calibrated attenuator. Now, what do you mean by the calibrated attenuator? The calibrated attenuator is nothing but the circuit which reduces the amplitude of the signal as per the our requirement or as per the scale. The AC voltage then been applied to the rectifier circuit which converts that AC voltage into proportionate DC, and that DC is then been applied to the analog to digital converter, and analog to digital converter converts that DC voltage to digital, and that digital voltage will be displayed here with the help of the digital display. Once again, the AC voltage is having the different ranges: 200 millivolts to 2 millivolts, 2 millivolts to 20 millivolts, 20 millivolts to 200 millivolts, and so on. Similarly, if I want to have the measurement of AC current, then the AC current is being passed. The rotary switch is being connected to pin number point number 3. That AC current is converted to current to voltage converter. So that is very, very important. So this current to voltage converter is going to convert that current into proportionate voltage, and then that current is been that voltage is been applied to the rectifier circuit. The rectifier circuit converts that AC current into DC AC voltage into DC voltage, and that DC voltage has been then applied to the analog to digital converter, and then that is been displayed. So for AC voltage or AC current, rectifier circuit is must. For the AC voltage, directly apply that AC voltage rectifier and convert it to DC and get it converted to digital and display. For AC current measurement, convert that AC current to AC voltage, rectify it, apply to the ADC, and ADC display ADC to display. For DC current and DC voltage measurement, we don't need the rectifier circuit because the voltage and current both are in the DC, and that's why if I want to measure the DC voltage or DC current, then directly connect it to the point number 4, current to voltage converter. That voltage has been directly applied to the ADC, and that has been displayed. If it is a DC voltage, then it is been applied to the calibrated attenuator, then it has been connected to the ADC, and then it has been displayed. So very simple circuit, very simple block diagram to understand the internal functions of the digital multimeter. The digital multimeter is basically been used for the quick measurements, quick testing and so it has been very small in size. It has been mobile. That means it can be taken anywhere that we want. So it has been operated on the battery, and that's why most of the times nowadays the display which has been used for the digital multimeter is the LCD type, liquid crystal display type, which is similar to that of your CalC display. And so here the multimeter is very useful instrument. Now let us check what kind of questions that can be asked on this multimeter. A digital multimeter is used for. So what are the different applications of the digital multimeter? Measuring AC and DC current, voltage and resistance. B, measurement of AC voltage, AC current and voltage, measurement of DC current and resistance, measurement of AC voltage and resistance. Actually, the digital multimeter has been used for measurement of AC, DC current, voltage, and resistance for all. Second question, in the digital multimeter, this is used to show the quantity under measurement. So what is being used to show the quantity under measurement? Right, digital display. So there is no analog display, there is no pointer or scale. There is a digital display which has been used for displaying the quantity under measurement. Which type of switch is used in digital multimeter to change the quantity and range of measurement? So as we have already discussed that there is a switch which is known as a rotary switch. So it can switch from one point to second point to third point so that we can have the measurement of the different quantities. Advantages or advantage of digital multimeter. So what is the advantage of the digital multimeter? It offers automatic output display. It ensures accuracy. It has auto polarity functions. Actually, A, B, C are all correct, and that's why all of this is very correct option. So the advantage of digital multimeter, it offers automatic output display. It ensures high accuracy because the measurement is being done digitally, and auto polarity functions is there. Suppose you connect the probe in the reverse polarity, reverse direction, then also it can display the quantity with the negative sign. So there is no damage to this type of the multimeter. Basic building blocks of the digital multimeter are, so what are the different blocks? Basic building blocks: oscillator, amplifier, diode, op amp, rectifier, Smith trigger, ADC, attenuator. So the correct option is an analog to digital converter and attenuator. These are the most important basic building blocks of the digital multimeter. Resistance is measured using. So what is the basic main important thing while we want to measure the resistance? Is it constant current source, constant voltage source, variable current source, or variable voltage source? Correct. It is constant current source. So with the help of the constant current source only we can pass the constant current through the unknown resistance, and the voltage drop across that is proportional to that resistance. The current is converted to voltage by passing it through a voltmeter, through a resistance, through an ammeter, through a galvanometer. So when I pass the current through resistance, then and then I will be able to convert that current into proportionate voltage. Okay. In digital multimeter, this is used to convert analog quantity into digital form. So here there is a counter, display, current to voltage converter, analog to digital converter. So analog to digital converter is the section in which the analog quantity is being converted into digital form. In digital multimeter, AC voltage or current is measured using. So what is basic main important thing about the digital multimeter while measurement of the AC voltage and current? Is it oscillator or op amp? No. Resistor or capacitor? No. Rectifier and attenuator. Rectifier and attenuator is the correct option, because rectifier converts that voltage, AC voltage or AC current into the DC quantity, and we can make it, we can supply it to the ADC, and ADC then is been used, the output of the ADC is been used to display it. Which type of the digital display is used in digital multimeter? So this is a very important question. So here in the digital multimeter, the display is not a 4-digit, 5-digit, 6-digit type of the display, because 4-digit display can display the information from 0000 to 9999. Similarly, for 5 digits or 6 digits. The digital display which has been used for the digital multimeter is known as the 3.5, 4.5, 5.5 type of the display. So here in this case, the most correct answer here is 4.5-digit display. It may be 3.5-digit display. So what do you mean by 3.5? What do you mean by the 4.5-digit display? 4.5-digit display means 4 digits full, 0000 to 9999, and the most significant digit is either 0 or 1. That means what kind of display we can have? We can have the display from, if it is 4.5-digit display, then we can display the information as 0000 to 19999. Okay, so that's why it is called as a 4.5-digit display. This is it for the digital multimeter. See you next time.